Hey, this is Avi Gutman with another Ask Me Anything event brought to you by quantreasoning.com. I invite you to join me live next time. We do this every Saturday at 11 a.m. Eastern, and you can attend for free by starting your free trial at quantreasoning.com. I have a pretty interesting question here, and what makes it difficult, I think, is the fact that it's three-dimensional. Because if it was one-dimensional, and I said that I have this length of 100, and I asked you how many times, or what's the maximum possible number of lengths of 12 that I could fit in, I think that would be a lot easier for you, right? How many of these 12s can I fit in at most inside a length of 100? Yeah, you would divide 100 by 12, you'd get a quotient and you'd get a remainder, because 100 is not a multiple of 12. And whatever your quotient is, that's the answer. That's how many 12s you can fit into 100. And I assume that you would wish that the 100 was a multiple of 12, because that would enable you to be more efficient, right? Nobody likes to have empty space when you're trying to maximize the number of some item that you can fit into something. And so I want you to take that kind of logic to the original question. This logic that says, if I want to really maximize, if I want to be as efficient as possible, I'm wishing for a situation in which the dimension that I'm trying to fit into is a multiple of the length that is going into that dimension. Okay, because that logic should help you kind of decide which of the green numbers should go with which of the red numbers in order to get the greatest number possible. And that's an important word here. We're trying to maximize. This is a optimization question, which I solved a lot of in my undergrad because I'm an industrial engineer. It was all about operations management and optimization. So you want to try to maximize the answer by being clever about which dimension goes with which dimension. And ideally, there would be some way to pair green and red together such that the red is a multiple of the green. Is there such a pairing that we could use? I mean, the 6 and 60 jumps out at me, because 60 is obviously a multiple of 6. Yeah, 96 is a multiple of 8, that's right. I know that because 96 is like 80 plus 16, and 80 is a multiple of 8, and 16 is also a multiple of 8. How many times does 8 go into 80 and into 16? It goes in here 10 times and in here 2 times, so it's 12. So it's 8 times 12. But wait, what about this? Is 72 a multiple of 9? Yeah, 9 goes 8 times into 72, 6 goes 10 times into 60, and we had a 12 here. So the answer is 8 times 10 times 12. Yeah, I would never just divide volume by volume because it's not that simple. Right? When you have if you had just a single dimension, like my first example, then you just divide one by the other. But the minute you go into 2 dimensions or 3 dimensions, weird stuff can happen. I mean, you could have, even in 2-dimensional, right? Maybe I have a square that's 10 by 10, and I want to know how many rectangles can I fit in, and what do those rectangles look like? Well, they're 1 by 100, right? So they're very skinny and very long. And if you just divide volume by volume, you'd say, well, area by area, you'd say the area here is 100, the area here is also 100, and 100 divided by 100 is 1. So I can fit one such rectangle in the square. But when you look at the visualization, you realize, no, of course not. I can't fit any of these rectangles in this square because these are really long rectangles. In this particular question, that would get you to the right answer. Why? Because every one of the red numbers had a matching green number that it was a multiple of. But if that hadn't happened, then that approach would fail. The reason that it worked out is because we could pair the numbers such that each red number is a multiple of its partner from the green numbers. But if that were not possible, It's very easy to make it not possible. Just change the 6 to 7.
If I was to do volumes with a 7 instead of a 6, I can still find the quotient and just, pray that the quotient is what?
Yes, then you would take the quotient, but you would want to minimize the remainder. Like when you're choosing which red number to go with which green number, effectively what you're trying to do is minimize the remainders. Now, in our case, we were able to minimize all the remainders to 0 because we were able to find pairs such that the red number is a multiple of the green number, in which case the remainder is 0. But if we couldn't do that, then we'd look at minimizing the remainders, but then at that point it wouldn't be a GMAT question anymore. At that point it would be a question that I would have had in my undergrad, and you'd have more than 2 minutes in order to solve it. So I wouldn't worry about that. Just conceptually, I hope that you can see why you'd want to minimize the remainders if you want to maximize the number of blocks that you can fit into the storage space. Because the remainders is empty space, essentially. It's unutilized space. Let me just show you another example here with a square. So again, we have a 10 by 10 square. And this time, let's imagine that we have rectangles that are 2 by 3, like that. And we want to fit as many such rectangles as possible into this square. So if you were to just divide area by area, you would say 100 is the area of the square and 6 is the area of the rectangle, and you get 16 2/3. That's how many rectangles we can fit. But if we try to actually place the rectangles in there, you'd have 5 rectangles, with 2, right? So it'd be 2, 2, 2, 2, and 2. So 5 rectangles. And how many 3s can you fit in here? 3. So the answer would be 15, not 16. You have all this unutilized area, and so it would be wrong to just divide area by area, because what about all this area that you're not even able to take advantage of? If you found this video useful, go to quantreasoning.com for a lot more where that came from. You should also click that like button and let me know in the comments below what you'd like me to make future videos about. And of course, if you haven't yet subscribed, go ahead and do that and click that bell below so you get notified about future videos. See you next time.